Hello everyone. In this session, we'll talk about what is correlation and what is covariance, when to use it and how to calculate it. So we'll go to the topic. So first, before we start what is correlation covariance, I just wanted to discuss a problem which I have, right? So I want to know if the price of the car increases, does the size of the engine increases or decreases? And maybe the other way around, right? If the size of the engine increases or decreases, whether my price increase or decrease, right? Of course, in general, right, the price of the car will depends on the engine size. But that's not only the factor. Engine size is not only the factor, but that's one of the major factor, right? So now but with this data, right, I just want to know how these two are related together, right? Is that engine size depends on the price depends on the engine size. So I just want to know the relation, right? So that's we call to find that we use correlation variance, right? So now let's talk about covariance and correlation, right? So what covariance is, right, is a measure of how much two random variables, in our case engine size and price, vary together. Or when we want to understand the linearity between two variables, we use covariance, right? uh, when you talk about covariance, right, it's like a variance only, right? But the major difference between variance and covariance is variance will tell you how single variable varies, where covariance tell you how two variables are varying together, right? That's the major difference between the variance and covariance, right? So when you talk about the disadvantages, the results of covariance can be minus infinity to plus infinity. So I cannot exactly say, this much percentage these two variables are correlated, or has some relation, right? So it is difficult to conclude how much both variables are varying or how much relation it has, right? That's what we discussed. So now we have correlation, right? Again, both correlation and covariance will tell you how much both variables are varying together. But the best part about correlation is the result of correlation is always between -1 to +1, right? With this, I can tell you how much two variables are varying together or correlated to each other, right? Now, very important points to be noted for the correlation is, right? Let's say if my correlation coefficient 1, which means every positive increase in one variable, there's a positive increase of a fixed proportion in another variable. Maybe we'll see the example, you'll be able to understand, right? Again, when I get -1, the other way around, right? So 0 means there is no correlation at all between two variables, right? So now we'll go to an Excel sheet and we'll see how try to calculate the covariance and variance. So before we talk, I would like to show the formulas, right? So this is the formula for covariance, right? So what I'm doing is I'm finding the distance. So obviously, right, I need to find the relation between two variables here. So x and y are two variables for me here. So where I'm finding the distance, calculating the distance from each point to the mean for both the variables and multiplying it, dividing by total number of observations. Here n-1, which is my degree of freedom, right? So this is what the formula for the covariance. When you talk about the correlation, so what I'm doing is I'm dividing by this covariance result by the standard deviation of x and the standard deviation of y. Got it? This is the formula of correlation. Now we'll go to our Excel sheet and calculate it. So obviously first I need to calculate the mean of engine. My mean of engine is 136 and the mean of price is yes. So this is my mean of price. Now as per the formula for the variance, I need to find the distance between each point to the mean for both the variables and multiply it, right? So distance of x comma y, I'm just naming the column. So here is equal to 130, right? The point to the mean minus 136 is my mean into this price minus mean of the price 18117.5, right? And now I need to do the same thing for the remaining variables. Yes, now let's find the sum of this, right? Is equal to sum of all these values. This is my sum. Now what I need to do, sum divided by degree of freedom, which is my total number of number of variables by 1, and this divided by how many I have. This is 14 minus 113, right? So yeah, this is the one, right? So we also have a formula in Excel, which is covariance for the sample of this engine, comma, of the price. Yeah, we got the same value. And when you want to find the correlation, right, this is the covariance. When I want to find the correlation, we know the formula. The covariance divided by standard deviation of X, which is engine size, and the standard deviation of Y, which is my price here, right? We also have STD, standard deviation of this, comma. Oh, this is I want to calculate the correlation here. Correlation of this, comma, this, right? So we got 0.60, which is like 60%, right? So I can say it, right? So there is an effect, right? So there is 60% effect. Let's say maybe I can conclude as increasing size of engine may increase the price by 60%. Maybe I can conclude it, right? So the another way, to find the relation between these two. So this correlation is obviously one of the way to find the relation, and we can also use scatter plots. It won't tell you the exact like 60% what we are seeing here, but at least we'll understand, right? And randomly, roughly how much it is varying. Yeah, can you see this? Somehow close, right? Maybe I'll try to plot. I'm just drawing a random numbers here, right? Maybe 1 into 2. I'm just multiplying these numbers by 2. 2 2s are 4, 3 3s are 9, 4 4s are 16, 25, 36, 8 8s are 64. Wow, I'm good at maths. Okay, so now if I plot a scatter plot for this, see, we almost got the straight line here, right? Let's find the correlation for this. Correlation between this, comma, this is 97%, right? So I can say this 97% relation between these two variables, because we are obviously increasing the size by 2, right? Got it? So now we'll also try to calculate the same thing in using Python. We'll use pandas here. Import pandas as PD, right? So I already have my engine price and this thing ready. Let me also run this. Just a second. Yes. Where's my price? Yeah. So I have a 2 list here. So I want to create a data frame from these 2 different lists, right? So for that, actually, there might be many other options to create a data frame from 2 different lists, but this is the option I'm choosing. So I'm creating dictionary for engine, engine, comma, price, colon price. Sorry, here let's see. Yes, I created my dictionary. So now I'm creating my data frame equal to pd dot data frame of d. Now if you see this, right, this is my size of the engine and this is my price, right? So in pandas it is actually easy to find the correlation. I said data.corr. It's very straightforward, right? You can see the result here. Let me undock this, right? Yeah. If you see, right, so the correlation between engine and engine is 1, obviously, right? The relation between the engine and engine will be always 1, right? If you see, the relation between engine and price is 60%, the same thing which we calculated, right? 60%, right? And of course, if the correlation between the engine and price is 60%, obviously the correlation between the price and engine will also be 16%, right? Both will be the same, right? So this is the way where we can calculate the correlation in pandas. So there is also another way using the visualization tools. So to find the correlation, so we have a concept called heat map, right? So what are the results which we have seen here? Those results will be, you know, populated in a heat map. We'll also see that. So I'm using a package called Seaborn. Oops, sorry. So let me run this. So in Seaborn we have heat map. I need to create a heat map for my correlation data, right, which I'm passing it here, and let me run this. So here I can see the plots. Okay, so there is another option. So here I can't see any values, right? I can see the dark values and the light values, but I just wanted to see the actual values, right? So unnet equal to annotation equal to true. Let me run this. Okay, there's another plot generator. Yeah, can you see this, right? So obviously between engine and engine it will be 1, and engine and price it is 0.6. Another way around, engine and price and engine is 0.6, right? So hope you enjoyed this video. Thanks for watching the video and stay tuned.